structure, union and enumerator. This video is a part 2 of structure. Pointer to structure and also called as structure pointer variable. So pointer to structure is a variable. It's hold address of structure variable. A pointer variable can store address of ordinary variable. A structure pointer variable can store address of structure variable. Structure pointer variable, also called as pointer to structure, can store structure pointer variable can store address of structure variable. Dot operator is used to get elements from structure variable. If we want to access the element of structure, we use dot operator. If we want to get the element from the structure pointer variable, we use arrow operator, that is hyphen greater than. So dot operator for structure variable, arrow operator for structure pointer variable. If we want to get or if we want to access the elements of structure variable, we use dot operator. If we want to access the elements from structure pointer variable, we use arrow operator. So main function structure book, character name of 25, character author of 25, integer call number. Static structure book B1 equal to, so that at the time of declaration we initialize the value. B1 dot name equal to C and C++ are stored in B1 dot name. In softtext is stored into B1 dot author. Then 108 is assigned to B1 dot call number. So we already discussed about the memory mapping of structure variable. So this example is a continuation of previous session. So in this statement we initialize at the time of declaration. So structure book star PTR, that PTR is a user defined name, but star PTR is a structure pointer variable. Here we use struct book star PTR. If we want to declare integer pointer variable, just we write like integer star k. If we want to declare structure pointer variable, just write like struct book star PTR. So PTR is a structure pointer variable. PTR equal to and B1. In this statement we assign address of B1 into PTR because B1 is a structure variable. So we get address of B1, then assign it into PTR. So PTR is a structure pointer variable. B1 is a structure variable. So address of structure variable can store it into structure pointer variable. So PTR is a structure pointer variable, B1 is a structure variable. For example, the address 108, that is address 800. Just we assume the address of B1 is 800. So that 800 is assigned to PTR. The size of PTR is 2 bytes because all type of pointer variable, the size of all type of pointer variable is 2 bytes. So PTR is also 2 bytes. But B1, the size of B1 is 52 bytes. That is 25 plus 25 plus 2. The size of B1 is 52. But the size of PTR is 2 bytes. This is also structure type, struct book type variable, but it is a pointer variable. So all the addresses are in integer format. So all pointer variable to store address. So all type of variable, all type of pointer variable occupies only 2 bytes. So the size of PTR is 2 bytes. So in our example, the B1 address of B1 is 800. That 800 is assigned to PTR. Backslash n percentage d B1 dot name, because B1 is a structure variable. B1 is a structure variable. If we want to extract the elements from structure variable, we use dot operator. B1 dot name, B1 dot author, B1 dot call number. So this is a structure variable. So here we use dot operator. The next printf statement, percentage d PTR arrow name, that is hyphen greater than PTR arrow name, PTR arrow author, PTR arrow call number. So ptr is a structure pointer variable. So that structure pointer variable has stored address of b1. So here we use arrow operator to get the value from structure pointer variable. So ptr arrow name, ptr arrow author. So it display the same result. This is accessing by variable. This is accessing by address. C and C plus softec 108 is the first printf. The second printf is the same result. Passing address of structure variable. We can pass the address. In previous sessions, we pass the element. We pass the structure elements by element by element. Then we pass the entire structure to the function. Here we pass address of structure variable, that is called by reference. So this program call the function by reference. So here we pass address. So we define the structure before the main function. If we want to pass the structure, entire structure or address of structure, we define as global definition. So structure book name, author, call number. So this is the definition. So main static structure book b1 equal, that is initialization and declaration. b1 is a structure variable. So it has 3 locations. The first location C and C++ stored in b1.name as softec and 108. So display of ampersand symbol b1, address of b1. The actual argument is a address. Here we pass the address of structure variable. So this is the actual argument. So the receiving area we should declare as pointer, structure pointer variable or pointer to structure variable. b2 is a pointer to structure variable. It can capable to store address of structure variable. So the address of b1 is transferred to b2. So the address of b1 is 800. The starting address is the address of b1. It transferred to b2. b2 is a structure pointer variable. The size is 2 bytes because all type of pointer variable size is 2 bytes. So it 2 bytes. b2, that 800 is transferred to b2. So that b2 is also has some address. It may be ordinary variable, array variable or structure variable, a function, it may be anything. But each and every variable, it independent of types. It has address. So 300 is the address of b2. Then b1 address is transferred to b2 800. So b2 represent the 800 from b2 arrow name, because we get value from structure pointer variable. So we use arrow operator, b2 arrow name, b2 arrow author. So it display C and C plus softec 198. Through this program we pass the address of structure to a function. We are also define structure within structure, that is nested structure. We can define a structure within a structure, that is structure address, struct address. Address is one of the structure. This is one definition. So it is a structure name. It consists of 3 elements. One is phone, city, pin. The size of this is the phone is 15 bytes, city 25. So 40 plus 2, pin is 2 bytes because it is integer. Totally the size of address structure is 42 bytes. Struct emp. This is another structure. That name is emp. It consists of 2 elements. Character name of 25. It is a character array. The second element is struct address A. The second element is a structure variable. This is a character array. The second element is structure variable. Struct address A. That A consists of 3 elements: phone, city, pin. So this is nested structure. This is structure within structure. In emp structure, we declare element as structure variable. So here we declare the structure variable static struct emp. Emp, this is the name of, this is a structure, emp structure, emp. What is the size of E? E consists of two elements. E consists of two elements. One is name, another one is A. But that A is a structure variable that internally consists of three elements. So E consists of four elements. E consists of two elements. One is name. Directly it has two elements. Name, character array is one, name is a one element. Then A is another element. That A is a structure variable. But it also consists of three elements. So totally four elements. So here we assign four values. Ninja 243101 OT 20. The memory mapping for E. So this is a E variable E. It's assigned 25 bytes. The size this employee structure, emp structure, the size of emp structure is the first element 25 bytes. The second element is a structure variable. What is the size of this variable? That is 25 plus 15, 42. So the size of A is 42. Name is 25. 25 plus 42, 67. The size of E is 67. So 67 bytes allocated for the E variable. So it consists of four locations. The first location name is E.name. E.name. The second location is E.a. That A consists of three elements. So E.a.phone. E.a.phone. E.a.city. E.a.pin. In E.name, so the Ninja is assigned to E.name. 2431011 is assigned to E.a.phone. The OT is assigned to E.a.city. The 20 is assigned to E.a.pin. That address is 800, 825, 840, 865. These are all the address. Because 800 is a first location address. Just we assume that address is 800. But E.name, the size of E.name is 25. So it occupies 25 bytes. The address of E.a.phone is 825 because 800 to 824, 25 bytes. So then it starts with 825. E.phone. The phone size is 15 bytes. It occupies 15 bytes. So 840. The E.a.city is 840. So it occupies 25 bytes. So 865 is a E.a.pin. So that memory, the memory is in continuous allocation. Then printf name equal to percentage, phone equal to percentage, E.name, E.a.phone, E.a.city, E.a.pin. Just display name Ninja, phone equal to 431001, city OT, pin equal to 20. Now we discuss about the union. Union also resembles of structure. But structure, the elements of structure is occupied individual memory. It's require individual memory for each and every elements of structure. But in union, it share the memory. If we want to save the memory, if we want to use the memory, suppose our computer has low memory at the time of invention, C language invention, the main memory is a very low in size. So if we want to save the memory, that is the usage of memory. We want to reduce the usage of memory, we use union. So the definition is also just like the definition of structure. So union, it is a keyword. There is a name of union. So elements of union. It is a declaration of union variable. K is a union variable. So it's just like a structure definition. Just a keyword only change. Union, union. So all other structure is similar to the all structure of union is similar to the structure definition. But it share the memory. So that element it share the memory. In structure is not share the memory. Each and every element of structure is required individual memory. But in the all elements of union is share the same memory. Example, so integer I, it's required 2 bytes. Character ch of 2 location, each location 1 byte, so it's also required 2 bytes. If it is structure, it occupies 4 bytes because 2 bytes for I, then again 2 bytes for ch. So the memory mapping of structure is like, that is totally 4 bytes. The 4 bytes is the 4 bytes has 4 into 8 bits. So this diagram represents bits for 4 bytes. So 4 into 8, 32 bits. It's allocate, it's required 32 bits. If we declare as structure, it's required 4 bytes. So this diagram shows in bit format. So it display 32 bit. So totally 4 bytes. First 2 bytes for I. First 2 bytes for I. Second one byte, that is third byte for k dot ch of 0. The fourth byte for k dot ch of 1. If it is a structure definition, if we define as structure, it requires 4 bytes. So I require 2 bytes, ch require 2 bytes. So it allocate 4 bytes. But the union case, in the case of union, this require 2 bytes. Ch of 2 is also 2 bytes. So only 2 bytes. It occupy only 2 bytes. K occupy, the union variable k is occupy 2 bytes only. Just like k dot I, totally 16 bit. Ch of 0 is share the first byte of k dot I. That is 8 bit. First 8 bit for k dot ch of 0. The second 8 bit for k dot ch of 1. So it share the memory. Then we assign k dot I equal to 512. The 512 is assigned to k dot I. K dot I, that is totally 16 bytes, 16 bit. The binary of 512 is 190. 190 is a binary of 512. 512 is a decimal, and internally it is stored as binary. So it converted and stored like that. That is 190, and the previous locations are 0. So this is the binary equivalent of 512. So that 512 is assigned. If we assign 512 to k dot I, it converted into binary. Then it stored. There is a binary. We discuss in previous example. If we store 512, just we put one box for 2 bytes. Then we assign 512 for readability. But computer cannot store decimal, but it stored as binary only. So integer totally 16 bits. In 16 bits, that binary equivalent of the binary equivalent of 512 is stored. The first byte, that 8 bit for k dot ch of 0 is access the first byte. K dot ch of 1 access the second byte. So totally 2 bytes is enough. For example, if we add another third element, that is float f. It is another variable, that is float f. Totally 3 elements. Just you assume, that is in ABC, integer I is a one element, ch of 2 is another element. The third element, just we introduce third element, float f. What is the size of union? I require 2 bytes, ch of 2 require 2 bytes, float f require 4 bytes. So which one is biggest? F is a biggest. So it allocate 4 bytes. That 4 bytes for f. The first 2 bytes for I. the first byte for ch of 0, the second byte for ch of 1. So it come more than if we declare more elements within a union, just we find the biggest size of the element. That size is allocated. The remaining variable are shared the same. In this case, f is a float variable. That size is 4, ch size is 2, I is 2. So it allocates 4 bytes. The first 2 bytes, whole 4 bytes for f, first 2 bytes for I, the first byte for ch of 0, the second byte for ch of 1. So the first byte is common for f, I, ch of 0. The second byte is common for f, I, ch of 1. The third byte for fourth byte is only for, is a portion of f. Here k dot I equal to 512, the binary of 512 is assigned here. The first location first byte is k dot ch of 0, k dot ch of 1. Printf k dot I, printf k dot I equal to %d k dot I. What is the value of k dot I? It display 512. By using %d, it display decimal value only. So display 512. If we print k dot ch of 0 equal to %d, k dot ch of 0, what is the value of k dot ch of 0? K dot ch of 0, this is the area of k dot ch of 0, that is 00010. The first byte is a location for k dot ch of 0. What is the equivalent decimal? 10 is binary. What is the decimal equivalent? 2. 10 is a binary equivalent of decimal 2, decimal value 2. So this location is 2. When k dot ch of 1, the 8 bit, all bits are 0. So equivalent decimal is also 0. But it display not 2. In k dot ch of 0, the decimal equivalent is 2. In k dot ch of 1, this decimal equivalent is 0. But it display k dot I 512. In k dot ch of 0, display only 0. Then k dot ch of 1, 2. It swap that. That is ch of 1 location value. Take k dot ch of 0. When k dot ch of 0 is take by k dot ch of 1. Because if we assign k dot I, we access k dot I only. If in a union, if we are use I in program, we don't use ch. If we use ch in program, we don't use I. So in any if condition or any one case selection, first we check. We can use any one of the element. If it has 3 elements, if we use first element, we don't use remaining 2 elements. If we assign 512 to I, we access that 512 through k dot I only. If we try to access the value, the first byte should be lower byte. The second byte is a higher byte. So it arranged like the first byte is lower byte, the second byte is higher byte. But in this case, this is a higher than this because 10 is a high value than 00. So it swap. The low values come to the first byte. This is lower byte. The higher values go to the second. This is a higher byte. So that's only it display. That's why it displays 0, 2. So basically union variable to share the memory, to restrict the usage of memory, to increase the speed of computer. If we use 2 elements in a function or 3 elements in a union, if we declare 3 elements or 2 elements, but it share memory, but we use only 1 elements. If we use first element, we skip other element. We use only any one elements, but we skip other elements. If we assign I, we access the value from I. We don't use ch. If we assign ch, we access the value from ch only. We don't use I. Enumerator is another type of user defined data type. This is also user defined data type like array, structure, union. Enumerator data types, we can define own data by using enumerator. We can define own data type and define the own values. It also prevents the wrong user input. If we want to get the input for marital status, sometimes the user enter single, sometimes the user enter unmarried. But the time of processing, if we consider only single, the other records, that is unmarried values, are omitted. If we use unmarried, the single are omitted. So, if we want to restrict the wrong input, so this is done by enumerator. This is example of enumerator. Enum This is a enumerator name. Name of enumerator empdef. This is the elements of enumerator. In structure union, we declare the variable. In structure union, we declare the variable. But here, just we give the values only. Assembly, manufacturing, account, stores are 4 values. So that enumerator variable can accept 4 values only. If we try to assign other value rather than 4, it will give error. So this is a enumerator empdef. So it consists of 4 values. We can declare the enumerator variable like empdef enum empdef k. K is a enumerator variable that k can store value of any one of the 4. So we can store any one of these values. If we try to store other value rather than 4, it will give error. Struct employee, character name n, integer a, float bs. So totally 4 elements is 4 elements in structure, employee structure. It consists of 4 elements. N of 30, a, bs, enum empdef d. D is a enumerator variable. In this D, we can store any one value, any one of the value. In this D, we can store any one of this value. If we try to store other value, it will give error. So it accept at the time of input, it restrict the user value. If the user give wrong value, it easily identify because only 4 department is there in that company. One is assembly, manufacturing, account, stores. By mistakenly, the user can enter computer department, but automatically it accept and stored it into the database. But if we use enumerator, we define the value. So these values only accept the variable. Any one of the value is accepted by enumerator variable. So D can store only one value from 4. So main structure employee E, structure variable E. What is the size of E? That is 30 bytes for N, 2 bytes for A, 4 bytes for BS. So what is the size of D? D is also 2 bytes. Internally, the compiler internally assign one integer value. We are also assign our own value. But compiler in this case it assign assembly is a 0, manufacturing is 1, account is 2, store is 3. If we want to change, if we want to assign own values, just assembly equal to 20, manufacturing equal to 40, we can assign. So otherwise compiler is assigned. Here we are not assign the value. So the size is, whether we assign or a compiler assign the value, the size of enumerator variable is 2 bytes. So 30 to 436 plus 2, 38. The size of E is 38. E dot n, Raju. We copy the Raju string to E dot n by using string copy function. This is an inbuilt function. So Raju is assigned to E dot n. That is, it has 30 bytes. So it's stored E dot n. E dot a dot 38. E dot a equal to 38. So we can directly assign that because it is a string. By using strcp, we copy the string to E dot n. It is an integer one. We directly E dot a equal to 38. E dot bs equal to 18575.0. E dot d. It's not a department. E dot d. This is a typo. E dot d. E dot d equal to manufacturing because the variable union variable name is d. Here E dot d equal to manufacturing. So the manufacturing is the one of the value of 4. That is assembly manufacturing account. It is a second one. Internally it treat as 0, 1, 2, 3. So a compiler internally it assign as 1 because manufacturing is 0, 1, 2, 3. If we give the one value, it assign one value for internal operations. So the manufacturing is assigned to E dot department. It is valid. If we try to assign rather than 4 value, assign a value, that value is not within the group, it will give error. Printf name equal to percentage, AC equal to percentage D, basic salary equal to percentage of E dot N, E dot A, E dot PS. So it display name equal to Raju, age equal to 32, basic salary equal to 18,1857. That result is basic salary. Then debt equal to not account. In this case, E dot D equal to accounts. That is E dot D. We assign manufacturing. E dot D is a manufacturing. Manufacturing equal to account. The condition is false. So it display debt not account. We can compare the enumerator value. We can compare the enumerator values with the enumerator variable. So to display not account. The type define. Type define is a technique is used to redefine the name of the existing variable type. If we want to give the meaningful name to the existing declaration, we use type define. Example, struct employee, character name of 30, integer age, float bs. So these are all the elements of structure. So this is structure definition. Struct employee emp. Here we type define. Struct employee is a declaration name. That is declaration type, data type. So we give the EMP, capital EMP is the substitute name for struct employee. EMP is the substitute name for struct employee. If we want to declare a struct variable, structure variable, just we put EMP E1 comma E2. EMP E1 comma E2. It's not necessary to write struct employee E1 comma E2. Just we simply write EMP E1 comma E2. So EMP is a type defined name. This is also called as macro. We discussed detailedly about the macros in a separate chapter. EMP is a equivalent name for struct employee. By using type define, we can give the meaningful or short name to the long declaration. So EMP is equivalent to struct employee. EMP E1 E2. This statement is equivalent to struct employee E1 comma E2. E1 just we simply E1 dot age equal to 40. That 40 is assigned to age, and then printf E1 dot age, it display 40. So emp is equivalent to structure employee, struct employee.